We are back. In the first session, I told you that I'm going to leave an activity behind on what I have so far taught. So the activity is here. Activity 6.1a. If you have learner's book for Baroque, you'll find this activity there. The activity I have told you, it is on the structure of an atom and introduction to nuclear chemistry. It is on reviewing the structure and the composition of an atom. So, as I told you earlier, you can pause and write down these questions which you are going to do, and I'll demand for their solutions. The first question is discuss the three major subatomic particles that you know. I have commented on that in the previous presentation. Hope now you know what those subatomic particles are. Draw the structure of an atom showing the location of the subatomic particles which you have named. That one is also easy. We have explored it in the previous presentation. You will copy and complete this table. So for this table, you will give a subatomic particle which you'll have named. For example, if the subatomic particle is Kalema-Bryan, you give the mass of Kalema-Bryan, you give the relative charge of Kalema-Bryan, you give the location of Kalema-Bryan. If Kalema-Bryan is the subatomic particle you've identified, you have to name it. I repeat, if the particle is Kalema-Bryan, the name is Kalema-Bryan, the mass, you give the mass. This mass you will need to research on the masses of the subatomic particles. You shouldn't hate research. So this is information available on the internet, which you can easily access. Then the relative charge, you give the relative charge of Kalema-Bryan. This is something also which you can find on the internet. You also give the location of Kalema-Bryan within the atom, if Kalema-Bryan is the subatomic particle. Then with the reason, state the region in an atom where the mass is concentrated. Here, you think about if the particle, if you have an atom, where is the mass of that atom concentrated? Is it concentrated on electron shells? Is it concentrated in the nucleus? So you have to think in that direction. Then you explain the following observations. You explain why atoms are electrically neutral. This is something that we saw in senior 2. Atoms are electrically neutral particles. However, you explain why we call them electrically neutral, yet they contain charged particles. They contain protons that are positively charged. They contain electrons that are negatively charged. So they have charged particles. However, we generally say that they are electrically neutral. You research and also give an answer to that question. We saw that in senior 2. You also explain why atoms of different elements adopt different atomic structures. Yes. Then for question 6, natural boron occurs. Boron is an element of the periodic table. So we can have boron of this form and also boron of this form. So they are telling you which term is used to describe these two forms of boron. So here we are seeing the boron can exist in 2 forms. This is also something that we covered in the concept of the periodic table. There is a term which we use to describe atoms of the same element, because these are atoms of the same element. They have the same atomic number, which is 5, but the atomic masses are different. Here we have 10 and here we have 11. So which term is used to describe those 2 forms? You have to also think about that. Then what is the difference between the atoms above and the subatomic particles. Then you also give, you state the meaning of the term nuclide. Here they are telling you share your findings with the rest of the class, no? You will share your findings with the teacher. Take note of that. You have to share your findings with me, maybe at school, or if you have some data on WhatsApp, we can chat. We can chat on this activity particularly, and I see what you'll have answered. And all of you have my contact. I need not repeat what my contacts are. So that is the activity. Very easy. As I have told you, it is very easy because these things have been taught in senior 2. They have also, I have recapped some of them in the first presentation on nuclear processes, which I have made. For further inquiries, feel free to contact me via my contacts, which you all have. Next, we are going to look at something else. I'm going to first, no, let me just continue. Let me not pause. Let us look at something else. Let us continue from where we stopped. However, as I've told you, can first pause, copy down these questions. Yeah, then you write the solutions to them. Where are we now? Okay. Let me share where we stopped. Okay. Let me see. Here we are. We had stopped on the structure of an atom. Now we look at the nuclear reactions, I think. Nuclear reactions. Having given the introduction to nuclear processes, now in this section we are going to explore the concept of nuclear reactions. So nuclear reactions, these are chemical processes in which two nuclei or a nucleus and an external subatomic particle collide to produce one or more new nuclides. Hope you've explored the meaning of the term nuclides. In that activity which I have given you, there is a question that requires you to research on what this term means, nuclides. So basically, nuclear reactions, these are chemical processes where nuclei can splint. Nuclei, this is the plural form of the term nucleus. So we can have nuclei splitting. Say if I have the nucleus of a heavy atom, say uranium, that atom is heavy, therefore unstable. It can split when it collides with subatomic particles like neutrons. However, we can also have combination of nuclei. If I have nuclei of smaller atoms, e.g., hydrogen, isotopes of hydrogen like deuterium, tritium, they can combine, they can fuse so that the process results in formation of the nucleus of a heavier atom. So those are nuclear reactions. So basically, we shall explore those reactions where the nucleus of an atom has to split. And also the case where we combine small nuclei of smaller atoms to form nucleus of a heavier atom. There are examples of nuclear reactions. We have radioactivity or radioactive decay, which results in emission of radiations. So it is also a nuclear reaction. We have nuclear fission, as I highlighted earlier. Nuclear fission, here we look at splitting of the nucleus of a heavy atom to form nuclei of lighter atoms. The nuclear fusion, here we look at combination of nuclei of lighter atoms to form nucleus of a heavier atom. So the products of these nuclear reactions may contain a different element or a different isotope of the same element, as we shall explore. We start with radiations and radioactive decay. Radioactive decay is the same as radioactivity. So radioactivity is spontaneous disintegration. Spontaneous disintegration, this is something that is uncontrolled. Spontaneous, something that is uncontrolled. You can have spontaneous, something that is feasible, occurs spontaneous, that is possible. Is the spontaneous disintegration, radioactivity is the spontaneous disintegration of heavy unstable nuclei to form simpler stable nuclei with emission of radiations. What this means in particular is that radioactivity refers to the process where we have nucleus of a heavy atom. Heavy atom, if you want to think about a heavy atom, you can think about uranium. Or you can think about, which other thing should I give you think about? You can think about atoms of elements that have high atomic mass and high atomic number. Those are heavy. If they are heavy, they have more protons. And since they have more protons, they are generally regarded as being unstable. So since they are unstable, they can disintegrate, they can break down spontaneously by emission of radiations. They have to break it down so that they achieve stability. If something is unstable, it will have to break it down. If it is a nucleus, it will have to break it down spontaneously to form simpler stable nuclei. And the process of it breaking it down is accompanied by emission of radiations. So on this, I am going to share. A sample illustration on how this radioactivity process occurs. So that is radioactivity. Then radiation is the emission of energy in the form of particles or waves. And the simplest examples of radiations you can think about, we have radiations of sunlight, we have radio and television waves. Radiations can also mean electromagnetic rays, such things. So radiations emitted during radioactive decay are known as radioactive particles. And the examples of radioactive particles, this is what I mean. I go back to radioactivity. I have said radioactivity simply means breaking it down of a nucleus which is huge into simpler stable nuclei. And once it breaks it down, That process is accompanied by emission of particles. So those particles that are emitted are known as radioactive particles. They include alpha particles, beta particles, and gamma rays. So we are going to explore each of these radioactive particles, and their, as in their description and their properties. But let me first display something on radioactivity that can help you understand better this concept of radioactivity. Allow me first pause.